Good morning, everyone. Yeah, we will begin. We have almost 11 people. Let me share my screen. I hope my screen is visible and I'm audible to you guys. If yes, please comment yes in the chat. Okay. Thanks, Vaishak. Yeah. So last week we had a discussion like writing our first code for our microcontroller, and we were able to blink the LED connected to microcontroller pin. I hope everyone's software is working properly as expected, which I helped in that last video, which is uploaded there in that YouTube. So we will dig deeper into the code and the related stuffs today. For that, we will open our software code. So here you can see we will discuss about this part later. This is essential part, but still we are not going to discuss about it today. For that reason, I am deleting it. So here you can see certain code session. So these two sections, I mean, from starting line number 1 to 6, this is called the comment session, where we explain the details, the basic details about the code, like which is the file name, who is the author, when is it created, and what is the purpose of the code, what are the major things taken care during writing this code, and which microcontroller it belongs. You can explain all the essential information regarding your code about in between this comment section. I mean, slash star, between slash star and star slash, between slash star and star slash, you can write anything, whatever you want related to the code, and you can keep it on top of the code. So what actually becomes when you write something in between this slash star and star slash is that the compiler, I mean the software, uh, which translates your code into microcontroller understandable code. Now I will bring our discussion to that area, what is microcontroller understandable code. So actually we have few different kinds of programming method. First one is machine language, which is directly uh, a play where we we will use only 0 and 1. First one is machine language. Let me connect one device, just a second. So our discussion is here now, right now. We are discussing about the comment section. So in comment section, we are writing a particular slash star and star slash combination. With the help of this slash star and star slash combination, we are telling the compiler not to uh, not to take this part of the code, not to take this part of the code for compilation. Then we went to discussing about what is this compiler and all those things. For that, I am here. We will discuss few things about this coding methods. Like initially in the ancient days, we used a particular method called machine coding. Like I am unable to write it properly. I will type it. Machine code. Why this font is like this? Machine code, where we will use only 0 and 1. The combination of 0 and 1, we are directly writing this value into microcontroller's register. Microcontroller register means microcontroller's internal memory area. Okay, so we are going to write 0 and 1 there, and we will manipulate things using this code combination. So after that, we invented, I mean, software people invented one method of programming called assembly language programming. Assembly language. There we are using mnemonics like move, a comma b, uh, move x comma bx, such kind of things you have learned, right? Or maybe you will learn in future. So these kind of coding methods are used in assembly language uh, programming method. But in C, you can see code structure like this: int a equal to 10, printf percentage d comma ampersand a return 0. Also, you can write a code like this. So these all comes under the modern programming language called high level language, um, or low level language, such kind of steps we will call. C is a low level language, but some debates are there telling that it's a high level language, or it's a combination of low level language and a high level language. But whatever it is uh, far more better than assembly language. Okay. So assembly language, it is very close to, I mean, machine language, it is very close to the microcontroller internal hardware structure, um, and assembly language is uh, comparatively closer to human language. But this C language and high level language is very closer to human language, like English. So we are interacting with the microcontroller using C program. So let us go back to the previous discussion. Uh, so in C program, our C program code, I mean this code is converted into machine code with the help of a tool called compiler. So our code, this code is converted into this code. This is the final executable code. Okay, 0 and 1, combination of 0 and 1 is the final executable code. So our high level language code is converted to this low level machine code with the help of a tool called compiler. That tool is a part of this software, MPLab X IDE. So this tool is a part of that C compiler tool is a part of MPLab X IDE. So what IDE means, that IDE is a combination of different software development tools. We will all learn it later, but we are discussing right now about compiler only. So what compiler does is it converts high level programming language into low level executable machine code. So with the help of this slash star and star slash, we are telling the compiler that don't take during the compilation. I mean, whatever you type in between these two lines, it will not consider for compilation. Okay. So this is the part comment session where you can write many things about the program which you are going to write. So we discussed in our first class that we are going to have an advanced level of C programming. So So whenever you are writing for an industrial kind of code, a code which is readable for everyone, that kind of that way, that time you have to maintain your coding style like this. So you will tell what all the essential details about your code like this. So this line number 1 to 6 explains the things like that, the important information related to the code, so that you can refer it in your future. After 6 months, you are opening the code and you won't be understanding majority of the things. So you will be using this way of representing things using comment. Comment means slash star and star slash. Okay, so wherever you want to say something, but not essentially need to compile, you can use this method, like this one. Also you can write something over here also if you want, slash star, um, star slash, and you are telling all the information related to this line, port b, why port b is equal to 0x and 1, 0x01. You can mention this kind of information. If it is a single line information, you can use double slash. It will exclude in the compilation. Okay, so slash star, star slash, and double slash. By using these two methods, you can write comments. Now, what is the next session? Yeah, next is header. We are discussing the structure of a C program today. Yeah, next is header. You can see one particular line written here. So this hash include this hash. It's telling the compiler we are including, after hash you are writing something, it becomes compiler directives. I mean, we are telling something to the compiler directives. It's an instruction towards the compiler. So we have many compiler directives coming, so we will learn it in upcoming lecture. So simply you can understand that the compiler is including something. Hash include xc.h. Compiler is including a particular header file called xc. Compiler is including a particular file called xc. Right now you can think in a way that the compiler, this xc file has many information related to compiler's internal registers. I mean, where are these port pin represents, where are these port pin represent, what all internal peripherals means ADC, serial communication. I will explain what all these things are, but for the time being, think in a way that xc.h is a file which contains microcontroller's internal essential information. Keep that in mind. Okay, so next line is hash define. This is also a compiler directive telling that crystal frequency. I mean the compiler, I mean the microcontroller has to have a external crystal connected, so that crystal frequency is 8 megahertz. So we are telling the compiler that if you see somewhere a, a letters or a combination of letter or a word like this, you can consider it as this one, 80,000. I mean 8 megahertz. Okay, 80,000 or 8 lakh. Let's count. It's 80 lakh. So 8 megahertz. So yeah, crystal frequency, you informed to the compiler it's 8 megahertz. Okay. Uh, then next thing you can see main routine. So this is the general C program structure. Header would be there, main structure would be there, and global variable declaration would be there, body would be there, return would be there. So it need not be follow the same structure, but Majority of the program, if you take any of the C program, you can see all of these things, but some changes would happen, uh, depend on the situation. Like suppose we need some memory location, we will declare it over here, int a equal to 10. So we will come into the discussion of variable declaration later in our course. So you can see some kind of structure changes in the general structure. So this is a general structure. So main routine, what is main routine? Main routine is a function. It's a function of our code. This is called main routine. Suppose we are writing something over here, it is called subroutine. Something, suppose if we are calling a delay, not delay, a display program. So we will call in that function, we will be doing something. So this display function, we can call it as a subroutine. So this is main routine, the main executable things would be inside that. So we can see some statements inside the main routine. Tris b equal to 0 x 0 0 while. So main routine, it start with the void main, or it can start with int main. What is the difference between void main, int main? We will discuss all this when we discuss function. Okay. So after this you can see few statements like here in this program it is int a equal to 10, print of certain data. I mean, here in this program, if you see, it's printing the value of 10 and returning a value 0. Here in our program, it is continuously blinking the LED by making port B equal to 0 and waiting for some minute, waiting for some seconds, then again making port B equal to 0 and waiting for some second. So this repeats because this is in while loop. We will learn loops when we are learning that particular section. Okay, I'm just giving an introduction. Okay, so these are the general structure. In a general structure, you can see these all things: header, main, variable declaration, body, and return. So people online, if you have any doubts at this point, kindly clarify, or else we shall discuss something interesting related to microcontroller and some other stuff by opening datasheet. So I am waiting for you. Anyone want to turn on mic and speak to me? Yeah, I really hope that the thoughts which I shared is clear to you. Okay. So this is the hardware which we created in Proteus for blinking the LED. Okay, so properties, why my LED is not blinking? I am thinking. So inside the embedded system weekly session, I created one folder LED blinking. I am opening it in distribution, default, production, open. Okay. Yeah, it is blinking. So we will have a little learning about microcontroller pick 16F877A now. For that, you all need to download its datasheet. Go to Google, type pick 16F877A datasheet. Yeah, the very first result you can open it. I am downloading it, saving it to desktop, embedded system weekly session, pick datasheet. Closing it over here. We'll open it there. Pick datasheet. So if you open datasheet in the very first page, when you have some time, I mean when you get some time, uh, go through the go through this particular document. First page you can see many information related to uh, its features, like what all this microcontroller can do, what all features it has. This kind of information you can get it from there. I will tell you what exactly a datasheet is. A datasheet is a document which that particular manufacturer, I mean, this particular microcontroller is manufactured by Microchip. Microchip is a semiconductor manufacturer. They manufactured the chip and uh, they started selling it to the selling it to people, I mean designers. So that time they have to release the document in the market also. So that time they release this particular document into the market so that engineers can refer this particular document and start designing things. So two types of engineer need data sheet. One is hardware engineers, one is software engineers. So what hardware engineers do with this data sheet? So I will show you that. For in this particular data sheet, you can see AC and DC characteristics, packaging information kind of thing. So let's talk about packaging information. So you can see many package information like what are the available packages. I mean, package information means how the IC would look like when you purchased. If you go for 28 lead and QFN, you can get an IC like this. And if you go for PDIP, you will get an IC like this. So when you're fabricating a PCB, these kind of steps matters, right? Like how much is the pin to pin distance, what is the thickness of that particular pin, and what is the distance between two lines of pins, total length of microcontroller. These all stuffs you can see under package information. So if you are going to manufacture a PCB, if you are a hardware engineer, you are going to refer the package information for creating footprints. Footprint means how the information for a PCB fabrication, how this particular microcontroller uh, will fit into a particular PCB. So this kind of information you will get it from package information. Then also, if you are a hardware engineer, you will always interested to these part also, electrical characteristics. So it will tell all the electrical characteristics like the working voltages, how much current it can handle through it pins. Such information would be shared over there. You can see VDD, what is the minimum VDD which it can. I mean, there are different variants of microcontroller. So there you can see minimum voltage it can support for this particular microcontroller is, this one is 4 volt. Maximum it can support is 5.5. If you give beyond 5.5 or less than 4.0, IC is not going to work. If you give for 5 point above 5.5, it is definitely going to damage the microcontroller. If it is 4.0, it is not going to work. It will go to some other state like sleep stage or reset state or something like that. Also, you will get some essential information like how the current, how much current your IC is going to um, withdraw from your supply, going to take your supply during the operation, and different at different frequency level and at different voltage level. Also, you can see the condition and all those things over here. Also, you will get some more information like how much your microcontroller's input output pin will handle uh, the current and voltage. So this kind of information you can get it from this section. So my industry right now, my interest is going to the device overview. So when you get some time, just open this document, just read it, whatever information you are finding it over there. If you have some doubts, try to use Google and find the answer of it, or you can ask me using the chat, I mean WhatsApp chat. So if you go to this, so you can see the internal architecture uh, of the microcontroller. There you can see many things, flash program memory, program counter, port A, port B, port C, these kind of steps. What are the peripherals? Okay. These kind of steps you can see. Okay. I'm trying to draw something. So this is a human being. I'm representing with as simple figure. So it has a brain, right? A human being has a brain. Um, it has eyes, nose, mouth, hand, legs, and many other um, organs. So if we consider microcontroller, if we consider microcontroller a big box, it has an internal brain. We call that internal brain as CPU. Think in a situation we only have brain, but we don't have any other organs to give information to brain and process. Brain has the brain has the feature or the capability to process the information and execute it, right? Suppose we want to take one bottle from a table, we need our hand support, right? So if we don't have hand, how we are going to take the bottle which we kept on top of table? So that's what here in microcontroller also. If our microcontroller has only a CPU, it can only process the information, but we need peripheral like GPIO is a peripheral. GPIO is a peripheral which can give information to CPU and which can take that CPU information to the output world. So here comparing our human being, we are processing the information through, we are getting the information through eyes, and we are telling something. Suppose a person coming towards to you, you are seeing that person coming towards to you and you are saying hello to that person with the help of your mouth, right? So for the microcontroller also we need such a such a scenario or such an information processing system. So here GPIO will give you some information and you will process it with that CPU, and uh, you will get that output using general purpose output feature of the microcontroller. Also the microcontroller has some other peripherals. So as we human beings have legs, hand, eyes, mouth, knows kind of things, the microcontroller has its own peripheral. This is microcontroller's hand and legs and mouth. Which are those? This timer, this ADC, UART, comparator, and ports called port C, port D, port A. These all are the microcontroller's peripheral. As we human beings have hand and legs, microcontroller have these kind of peripherals which helps the microcontroller to fetch the information from the outside world and to give it back to the outside world using its peripheral. These are some of its peripherals. We will learn it in future one by one. When the times suggest that we need to learn this particular part of the peripheral, we will come and learn it and we will execute it. Okay, so this is just an introduction. This is an important document. Just download, you guys just download, and when you get time, just go through that particular document. Okay, now what's next? Okay, I opened my syllabus here. Let's see. So we covered this basic structure of C program, your first Hello World program. Okay. Uh, so this was your first Hello World program. Whenever you choose, whenever maybe after some of our classes, maybe after 1 year you become an embedded system designer, uh, and you got a job in a particular company. There you are instructed to write a particular code for a particular microcontroller, not PIC16F877A, some other microcontroller manufactured. Maybe we will take an example from Renesas microcontroller. So Renesas microcontroller, you got a particular motherboard of or development board of Renesas microcontroller. Let's see one Renesas microcontroller development board. Okay. So this is Renesas microcontroller development board. Uh, your company, your team gave gave you this board, and they told you to write a program. Okay, but you are very fresh to this particular board. How will you proceed? You can proceed with the help of the manual, but the point of discussion is different. So, suppose you guys are learning general purpose programming languages like C, C++, Java. Everywhere you are beginning with an Hello World program. So, their Hello World program is something like that. Writing a Hello World, I mean printing a Hello World in the screen. Let's open one online compiler. You can see it over there. I'm opening one online C compiler. So here in online C compiler, you can see one particular called came default. Of, mm, Came default. So here you can see print try programmings pro. Okay, I am opening a different compiler, online C compiler. That is from this is from programmings.com, and I will open a different one, GDP online compiler. There also you can see one default code came. Here printf hello world. So most of the time when you are going to Java, learn Java, the first code you are writing would be hello world program. Let's see the execution. Hit run. It printed hello world in the console. At the console you can see hello world printed. You can change this. You can keep your name. Sri Kumar. It will print Sri Kumar over there. And if you missed some semicolon, it will not compile and it will tell error expected a semicolon before return. Yeah, so we have to put it. So you can always explore these kind of online tools for learning C program. I suggest this online C compiler. Write your code, learn it. So what my point is, Hello World program is something which helps us to test the compiler or test the environment which we are going to use to create some project or some good stuff. So here our Hello World program is this one, blinking the LED, and you got a job in a particular company, and they gave you this particular board, and they assigned something to you. They told create some program for reading a particular temperature from a sensor and display it over LCD using this particular board. Then you got some work, right? So you have to understand how the board is going to work. So every individual coder will run a particular code to check what all whether this board is working fine. That essential code which he is going to write at first is an LED blinking code. So um, what I am going to say is that for an embedded system engineer, the Hello World program is blinking an LED. Okay, so whenever you got a particular new microcontroller, try to run a particular code like blinking an LED using its GPIO. GPIO means general purpose input output. Okay, so GPIO, these all are GPIO. These all are GPIO. Uh, I will tell you in the upcoming class how can we classify the pins, which are power pins and which are GPIO, which has um, additional features, or which pin can act as only GPIO, and which pin can act as analog, and which pin can act as some other communication pins, and all those stuffs we will discuss in the upcoming sessions. So what my point is, whenever you get a new board, try to write a blinking code, LED blinking code. Most of the development boards would have an onboard LED soldered so that the developers can test their first code using that particular onboard LED. Uh, yeah, so this is our embedded software designers. So this is our embedded software designers Hello World for PIC microcontroller. This will blink that particular LED which is connected to port B. We will dig deep. Just okay. So we have discussed these two steps in the syllabus. I am strictly following the syllabus because I am not missing the essential things discussed to be discussed. So uh, overview of programming language, you guys just Google it and learn. But I will give you some basic idea, like how this programming language evolved. Like initially these microcontroller and programmable devices were programmed using machine language. As I told in the beginning of this session, we were used we used it to program these kind of devices using 0 and 1. We will write the values, necessary values, by making the combination of 0 and 1 or hexadecimal value, and we will write it into the chip with the help of some special devices or with the help of a software called a hexadecimal editor or such kind of stuffs. With the help of those hexadecimal editor, we will write the code. That kind of coding, I mean, the machine coding is a tedious stuff. It is very hard to learn and maintain the code. It is erroneous. Lot of errors. There are many chance to come or create. errors. So later machine language came. After machine language, we got uh, assembly language code. There we have mnemonics. With the help of mnemonics, we are interacting with the microcontroller, and we are telling the microcontroller to do the steps with the mnemonics. After that, in programming language, there were many programs came like basic. After that, basic C came. Uh, basic started with B, right? Then with the B, one particular guy called Brian Stostrup, yeah, or some other guy. I don't remember who invented C, some Riche or someone. Okay, after B, basic C got introduced. After C++ introduced, Java introduced, Python introduced. So many languages came into picture. This is the thing which I wanted to discuss in overview of programming language. Whenever you get time, go through the history of the programming language and its evolution. It will give you an idea of different facts lying behind this programming language. Okay, now we will quickly jump to variable and data types. Okay, variable and data types, and it is very essential for us to move forward. So, okay, so what is variable? Variable is simply a memory location inside the microcontroller. Suppose we want to store any data. Suppose inside the microcontroller we want to store an information regarding an external input, say temperature. So we are getting some external data from GPIO, an ADC, ADC data from an external word, and we have to store it somewhere inside the microcontroller. So this location we are getting it with the help of compiler. Okay, so we are telling the compiler that we need some memory location, and we are telling it with the help of variable declaration. Okay, variable declaration is two type. One is global variable and another one is local variable. Okay, I will tell what is global variable and local variable. I told variable is a memory location. Suppose you are writing like this, char x and semicolon. It becomes a global variable. Suppose you are writing inside the main routine char y equal to, sorry, y semicolon. Then it becomes a local variable. Also, here in this particular subroutine, a subroutine is a routine which is not part of main routine. Okay, just keep in mind that we will discuss those things when we discuss function. Okay, inside this display function we are writing int, not int, we will use char only, char z. Okay, okay. So here x is a global variable, y is local variable, and z is local variable. What is the difference? So char y and char z is only applicable, only visible to display and main. I mean, whenever the main routine executes and it hits somewhere like inside this particular code we are writing some something like this, y equal to 0. Okay, y equal to 0, it is mm, allowed. It is allowed. The compiler won't say anything because the compiler know what y is. Y is a memory location of type char. Okay, our discussion is variable and data types. Okay, so here what I wrote, char y. Okay, so y is the variable and its type is char. What is mean by char? Char means character. It can hold 8 bytes. Okay, So there are different kinds of variables, and I will tell you that. What are those different kind of variable? Those are char, int, float, double. Okay. In embedded system, there is one more variable which we use. It is bit. Bit, char, int, float, double. Okay. Bit, char, int, float, and double. Suppose if we are using bit data type for representing a memory location, it will take only bit, one bit, not byte. Okay. Suppose if you are using a char to declare a variable, it will take 8 memory location, 8 bit. Suppose we are using int, it will take 16 or 32 bit of your particular memory allocation based on your microcontroller. Okay. In lower variant like pick and all those stuffs, it is 16, and when it comes to ARM microcontroller or the bigger uh, architecture microcontroller, this int would be 32. Float is also 32, but in bigger microcontroller it may be 64. Double is also 32, but there is some other consideration. Float and double are used for decimal point storing. Like if you have some temperature coming like 10.32, you have to declare a variable or define a variable using float or double. Okay, we will learn those things later. Let me begin the basic, proceed with the basics. Okay, so what char y? So char y means it can hold 8 bits of memory. 8 bits of memory means you can progress from 0 to 255. I mean, you have few numbers starting from 0 to 255. You can store it over char y. So char size is 2 raised to 8, 8, right? So you can calculate like this, 2 raised to 8, which brings you 256, right? Yeah. So 0 to 255 counts 256. So these um, many decimal values can be stored there. Up to 255 is the range. So char y, and we have char x, and we have char z. I was talking about the visibility of that variable. So the visibility of char y would be inside this parenthesis. I mean, inside the main routine only, you can access this particular variable. You can access this particular variable only inside the main routine. This char z is accessible only inside this display routine. But in the case of z, in the case of, sorry, in the case of x, it is accessible all over the program. I mean, it's a global variable declaration. You can see it is declared just after our header file inclusion and some macro definitions. Okay, so here char z is a global variable which is accessible all over your code. You can write it like here, like x equal to 1, you can write it like this. Okay, I'm compiling this code. Let's see what a compiler tells to me. For compiling, just select a clean and build. Yeah, it's the clean is successful. Let's see for some, yeah, this is not understandable, so they are telling what it is, so I am deleting it. Clean and build. Yeah, the build was successful. uh, I am writing one more thing over here. uh, I am writing z equal to, I am trying to write a value 12 inside the memory. Z is the memory, and I am trying to write something, a value inside the Z, and I am trying to compile it. Let's see what happens. Yeah, the compiler is telling error, use of undeclared identifier Z. Z is defined only, declared only inside the display, right? So it is local to the program, local to the display code. So if you write something, so I am commenting it, I am removing the code line, and if I go through the compilation, it will compile, right? So here I am writing something inside this display function. I am writing something z equal to 12. Okay, let me see whether it allows me to write it like that. Should definitely allow. Yeah, it it is allowing. So z equal to 12, it is not allowed inside the main routine. The reason is z is not at all declared inside that main routine. Z is declared only inside the display subroutine, but x is declared as globally. So x is accessible throughout the program. So whenever you need a memory location, think whether it is a global variable or local variable. So whenever you are going to write memory constrained programs, you have to think in a way that whether this memory is going to be a global variable or local variable, like that. So when you want to reuse your memory and you want to save your memory, preference is to create local variable. And when you have to create a memory location which is going to be permanent and accessible all over the code, your goal is to create a global variable. So we discussed too many things till now. Anyone wants some clarification about the things which we discussed till now? Please turn on your mic and ask me. So our discussion reached till here only. There are many to go. It will be interesting. So we need some basic theory. That's why we are discussing all these stuffs. Once we get a minimum theory regarding the programming, we will start. We will continue with the practical things like this. Okay, creating schematic and writing the code. So variable declaration, memory are those essential things. Maybe next class we will stop the discussion of variable declaration till here, and we will jump into control structures, and we will do some steps using this control structure. If you learn to use control structure, we can write some cool codes for testing the hardware. Okay. So be patient. There is a lot to learn. The journey is going to be interesting, and you will learn steps. I hope there is no doubt. Okay, the video which I am sharing is one of my channel. I recommend you to subscribe it. It's not necessary to subscribe it. If you wish to subscribe, you can always do. Sometimes I post videos uh, which is very necessary to support our discussion, which will take time to create. I mean, the discussion beyond the scope of this course, I will put it over there, but it would be an add-on for your embedded system journey. You can watch it if you want. Yeah. Yeah, I will take a few more minutes of you. So these are the this is my plan for this course. As a beginner, we are going till here functions. Okay, so till functions we will learn as a beginner. So what will we what will be doing as a beginner? As a beginner, we will be doing all these steps to uh, become a good beginner. So we will be blinking an LED. It's already over. With the help of blinking LED, we will learn variables and data types. Still, it is not over. I mean, the discussion is still ongoing. And next project would be switch and LED. We will interface one switch to the microcontroller with the microcontroller, and we will uh, control the LED with the help of that switch. So at this stage, we will discuss the microcontroller architecture related to the GPIO and software development tools in deeper. And next thing is automatic temperature controller. We will make one temperature controller. For that, we need to learn the control structure. Control structure means, we'll go to this. Control structure means conditional statement, if and else, logical operators, switch case statements, loops, break and continue statements. These all things are required for completing this particular project called automatic temperature controller. So if you learn this conditional statement and some loops, you can do this project. Conditional statements and loop, with the help of these two learnings, you can do that particular automatic temperature controller project. Okay. After that, we will make some some bigger project, password based door lock. So there you have to learn the control structure part 2, the remaining part of control structures. Okay. After that, we will do a project called computer based data monitoring and device control. We will make a circuit which can interact with computer, okay, a laptop or some stuff. There you will learn a UART peripheral. Also you will learn the communication protocols which are there in the microcontroller world. There are many, but the basic stuff is UART. After UART, we have I square C coming in inside the intermediate, and in expert level we have other protocols also. So it's a basic communication protocol. That is why it is in the beginner stage. So this is the steps which we are going to learn in the beginner stage. After that, in intermediate stage, we will start using the intermediate concept called pointer and strings. By using pointer and strings, we will start interfacing LCDs, and with the help of that, we will do one more project called voltage reference calibration tool. There we will interact with a particular chip called MCP2941. The communication is based on SBI protocol. From this stage onwards, we will start following the clean code concept which we use in the industry. Also after that, we will create one alarm clock where we will learn I square C. In expert level, we will start in learning installation of STM32, the advanced microcontroller, and its environment. There we will do one LED blinking code. We will start learning structure and loop. Okay. Then we will end our course. So this is the 10th step. If you reach at this point of at this level, the course is complete. Yeah. So this is the path or the roadmap of the course. This is what all I want to interact with you guys today. Maybe we can make we will meet next week. Not we can, we will meet next week, and then we will make the progress of the remaining stuff. Okay. So see you all. Have a nice weekend. Yeah. Thank you. Bye bye. Also, I have this session recorded. I will post it on YouTube because a few of uh, people are missed this class. They requested me to record it, so I will post it. Uh, Vijay Shata, you want to ask something? Okay, thank you, Kartika. Thank you.
No, 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 no.
Okay, okay,
He's missing it.
okay. So we'll meet you next week. Yeah. Bye bye.